Howdy. For our bell ringer today, I want you to consider this activity graph on the screen and answer the following questions. There are 5 times on this activity graph, A, B, C, D, and E. In order to finish this activity or the complete activity, let's think about it. The sum of the 5 times is 7 hours. If you add all the time it takes to do A, B, C, D, and E, it takes 7 hours. The question is, will it take 7 hours to get ready for the party? Furthermore, if all the activities could be performed simultaneous, how long would it take to prepare for the party? I want you to think about this for a second. Pause this video, and I need you to write down what you think the answer to this is. All right. So now's the time where we share good things. Every day I want you guys to think about what happened in your last 24 hours, or maybe you didn't get to share in the past. What's happened in the last week in your life, in your personal life, in your family life, in your friends and everything. See if there's anything you can share. Last night was a good day. I worked really hard all day, got home, and I went straight to bed and had no problem sleeping at all. And that's kind of a new thing for me because I'm usually up all night. Anyway, that's a good thing for me. May not be good for you, but getting sleep is always a good thing. So, lesson objectives. I can create maps conforming to specific coloring properties, and I can use graph coloring to model a scheduling problem. And I will analyze graphs to determine the number of colors necessary to color every region. All right. So let's revisit that activity graph we saw on the bell ringer. You're in charge of organizing the senior class party. The following graph and activity table is your estimate of the time required to perform all of the activities that are necessary to get this thing done. All right, activity A, plan music playlist. It takes a half an hour. Activity B, download the music. That takes an hour. Activity C, buy groceries and decorations. That takes 2 hours. Activity D, bake the cake and prepare the food. That takes an hour and a half. And activity E is set up. It's 2 hours. Now, since there are several classmates helping, some of these tasks can be performed at the same time. For instance, people can begin setting up the decorations while the cake is baking. However, you cannot bake the cake or set up until after the shopping has taken place. And you cannot begin downloading music until you know what songs you want to download. So the following activity graph can be used to help organize this information. So let's think about this. This is actually a vocab word. An activity graph is a graph that shows all the activities in the order in which they need to be performed to finish a task or series of tasks, and the time that takes for each one. It's almost like the graphs we've been doing with weights on them, except the weights aren't on the edges now. The weights are on the activity themselves. So it looks kind of like the graphs we've been doing, but it has a little bit of different twist to it. So, all right, what do the numbers represent in the graph? We just discussed it. If you go back here and you look at the table, it tells you it's time in hours. It says activity A is an hour and a half. If you come over here and look at this graph, 0.5 is in that little diamond that represents activity A. So we know that the numbers represent hours it takes to do that activity in the task, or that task in the activity graph. Okay. Why is there an arrow from activity A to activity B, but not from activity A to activity C? Well, think about this for a second. If we go back 2 slides, activity A is to plan the music playlist, and activity B is to download the music. Activity C is buy groceries and decorations. Do we have to plan the music playlist before we go to buy groceries and decorations? Now, while some of you may say, yeah, I've got to have music to go grocery shopping, that's not the case in this particular instance. The reason why there is not an arrow from A to C is because A is not a prerequisite task to go on to activity C. However, activity A is a prerequisite task for activity B. You must pick your music out before you download the music. That's what A and B are. C is buying groceries. So no. Now, if there was an activity A.5 or whatever you wanted to call it that said plan grocery list, that would be a prerequisite to activity C, buying groceries. Now that makes more sense, doesn't it? All right. Beginning at start, there are several paths through the graph following the arrows that end at finish. For each path, calculate the total time required to perform all the activities along the path. All right, the first activity path we see is AB. To get through activity path AB, it takes a half an hour to do activity A, and then it takes a half hour to do activity B. Activity A was to pick your download list, plan the music you're going to have for the senior party. So that takes a half an hour, and then downloading the music takes an hour. So that whole path takes an hour and a half, start to finish. Now, activity path CD, to go grocery shopping and pick up supplies takes 2 hours. And then we go on to activity D, that's baking the cake. It takes an hour and a half. And then it's finished. And the total time for CD is 2 hours plus an hour and a half is 3.5 hours. And then there's one more path. After we go grocery shopping and pick up supplies in activity C or task C, we go on to task E where we do setup, and that takes 2 hours. The total sum of CE is 2 hours plus 2 hours or 4 hours. Now, note that all three of these pathways can happen simultaneously, which means at the same time, if you did not know that. So, what is the minimum amount of time required to perform all 5 activities? The minimum amount of time required to perform all activities in an activity graph is the amount of time it takes, the maximum amount of time it takes to finish the longest or the maximum pathway, the maximum time pathway. So AB can be done in an hour and a half. And if CD can be done at the same time AB or B, let me rephrase that. If AB and CD can happen at the same time, AB will finish before CD will because AB takes an hour and a half. The CD takes 3.5 hours. However, CE takes 4 hours. Since CE, CD, and AB happen all at the same time, the minimum time to complete all 5 tasks would be the maximum path length. So CE is the longest, it's 4 hours. Since they're all happening at the same time, AB would finish in an hour and a half. Then CD would finish in 3.5 hours, and a half hour later, CE would finish, and all the activities would finish, and they'd be ready for their party. All right, which path corresponds to the minimum time? That is CE. CE is what activities are along this path. C is grocery shopping and picking up supplies, and E is setting up the party. Those both take 2 hours. 2 hours plus 2 hours is 4 hours. That's longer than 3.5 hours for CD. That's longer than 1.5 hours for AB. So we could put just 3 people on this task and we can get it all done. We put one on A and one on C. A would finish and go on to B, and he would be done as soon as C got done with 2, and then one of them could go to D and one of them can go to E. So you really only need 2 people on this task. But that's not part of this assignment, just something to see. You can actually do the minimum number of people required to complete all tasks. That's not part of this assignment. It is something that to consider if you're ever doing project management, which is a really well-paying job in the future. What we're doing right here with activity graphs is a very fundamental part of project management. If you're interested in project management, see Coach Primeaux, and he can direct you to the College and Career Center where they can tell you what kind of education you need to get that. All right, which activities could take a little longer to complete without affecting the total completion time? Now, it seems like it's a tricky question, but it's not, okay? So if C and E take 4 hours to complete, that means C and D only takes 3.5 hours. D could take an extra half hour and still get completed at the same time CE does. Consequently, A and B, which only takes an hour and a half, it could actually be postponed probably, 2.5 hours, or it will be done 2.5 hours before CE is done. So we could take a little longer. We could put an extra hour or an extra 3 hours on A to plan the music list and get the perfect playlist for the party, because it takes so long to complete the buying the supplies and setting up the party. So which activities could take a little longer. A could take a little longer, B could take a little longer, C cannot take a little longer. We'll discuss why in a minute, but D could take a little longer. Remember, C and D are on the same list. They're a shorter path, but C is a part of CE. So if we postpone C, what happens to CE? The minimum completion time gets affected. We'll discuss that in the next slide. Well, not in the next slide, but you'll see. Scheduling classes in college can be very similar to the previous scenario. Now, over 4 years, there are certain classes that you must take. Many classes have prerequisites. That's classes that must be taken first. That is part of your vocabulary, the word prerequisite. Prerequisite means these classes or activities are required before you go on to the next activity, okay? And it says classes that must be taken first. Suppose you need to take the following classes with identified prerequisites. So the table we have here is a list of classes in column 1 and a list of prerequisites that are in column 2. So in column 2, if there's none in the prerequisite, there's no class required to take before you take that class in column 1. As you can see, Calculus 2 requires you to take Calculus 1 before you take it, because in the prerequisite column adjacent to Calculus 2, which is a class that you seek to take, it says the prerequisite class for that is Calculus 1. Notice also that in Physics 1, Calculus 1 is also required to be taken before you can take it. This goes for Physics 2, you have to take Physics 1. But in order to take Physics 1, you have to take Calculus 1. Psychology 1 has no prerequisite. Speech also has no prerequisite. But argument and debate requires you to take speech first. So, 7 says, construct an activity graph for this situation using the following rules. Create a start and finish square. Any activity that can be performed right away is connected to start. No prerequisites, we start right on those activities. Activity A is connected to activity B by an arrow only when activity A needs to be performed directly before activity B. That is just a line that describes this prerequisite for another activity, or in this case, class. Any activity that does not precede any other activity can be connected to finish. So any of these activities here in class, okay, that is not a prerequisite for another class. So any activity over here that is not also over here can go directly to the finish line. So let's take a look at this. This is the completed activity graph. We start with 3 courses or classes that do not have prerequisites. They are Calculus has no prerequisites, or Calculus 1. Psychology 1 has no prerequisites, and Speech has no prerequisites. So right out of the bat, right out of start, Cal 1, Psych, and Speech are all taken with no prerequisites. All right. Now, Calculus 1 is a prerequisite for both Calculus 2 and Physics. So there's an arrow coming out of Calculus 1 going to Calculus 2, and an arrow coming out of Calculus 1 going to Physics 1. You see that? Okay. Now, Calculus 2 is not in this prerequisite list. Because it's not a prerequisite list, that means that when you're done with Calculus 2, you can go to the end section because it is not a prerequisite for any other course. Now, Physics 1 is a prerequisite for Physics 2, as you can see here in the table. So that arrow comes out of Physics 1 and goes to Physics 2. Physics 2 is not a prerequisite. It's not in the prerequisite column at all. So we can take an arrow and it goes straight to end. Now, in the speech activity path, we have speech, and then the only prerequisite it is a prerequisite for, or the only course that it's a prerequisite for, is argument and debate. You see speech is in prerequisite, and you see an arrow coming out of the diamond for the activity of speech to A and D, or argument and debate. Argument and debate is not in the prerequisite column. It's not a prerequisite for any other course, so an arrow goes straight to N. And that is your complete activity graph. Now, while this may seem really complicated, this is just a fundamental beginning of way you're going to do your classes when you get to college. So this is kind of important to understand. Your counselors in college will seek to help you understand this as best as possible, but unless you understand it truly, you really don't know how long it's going to take you to graduate college. Every time you fail a course or you don't do well and you want to take it and get a better grade, you postpone this whole activity graph. So identify the longest path from start to finish. And how long is this path? Well, let's look. This takes 2 classes. This takes 2 classes, but this one takes 3 classes. You might notice that psychology doesn't have an arrow coming out of it. I'm going to be honest with you. That's my mistake. There should be an arrow coming out of psychology going straight to the end. Because if you go back one more, you'll see that psychology is not a prerequisite for any other course. When I made this, I completely forgot about it, but I think you can understand that there's nothing coming out of it. It should go to the end. All right, identify the longest path. Longest path, Cal 1, Physics 1, Physics 2. It takes 3 courses. All the rest take 2 or less. If each class is a semester long, how many semesters are needed to take all classes? Okay, well, let's think about it. This path, Cal 1, Cal 2, is only 2 semesters. This path, psychology, is only 1 semester because it goes all the way to the end. This path, speech and A&D, is only 2 semesters. But this path, Cal 1, Physics 1, and Physics 2, is 3 semesters. So in order to finish all classes, how many semesters will it take? 3 semesters. If you want to finish these classes as soon as possible, which classes should you not delay taking? That's pretty simple. If you want to finish it in 3 semesters, you can't delay Cal 1, you can't delay Physics 1, and you can't delay Physics 2. You can't wait a semester at all. And this is why your counselors say it's very important to try hard the very first time you take a course, because every time you do poorly in a course and have to retake it because you didn't make the mustard in order to go on, or you failed the course and you have to take it just to get a grade that's passing, you're going to postpone this entire mechanism, this whole activity graph. Supposed to only take 3 semesters. Say you fail Cal 1. That puts you back a whole semester. Now it's not only going to take you 3 semesters, it's going to take you 4. What happens if you fail Cal 1, take it, pass it, then fail Physics 1, take it, then pass it, then fail Physics 2, take it, and then pass it again? That's going to take you 6 semesters. That's a year and a half. I mean, you get the idea here. How long could you delay taking psychology without delaying your overall program of classes? The longest pathway, we said, the minimal time to complete all paths, is 3 semesters. Psychology is a pathway all by itself. It's only 1 semester. We could delay taking psychology for 2 full semesters and take it in the 3rd semester when we take Physics 2. Does that make sense? That way, Physics 1 wouldn't be in this 1st semester, and it wouldn't be in the 2nd semester with Cal 2, Physics 1, and A&D, which is argument and debate. We could put it all the way back into Physics 2. Because as you can see, in the 3rd semester, the only class you're going to take is Physics 2. Instead of trying to put it all in that 1st semester, you could push that all the way back there and even out your courses. And that's what your counselors try to do when they help you take courses when you're in college. All right. How long can you wait to take speech without delaying your overall program of classes? Now look at the pathway that speech is on. There's speech and argument and debate. The longest pathway we said was Calculus 1, Physics 1, and Physics 2. That's 3 semesters. In order to get done in 3 semesters, speech and A&D is a 2-semester pathway. We can only delay it by 1 semester and still remain inside the 3-semester threshold. That is that Cal 1, Physics 1, and Physics 2. So the answer is you can only delay the speech class by 1 semester. All right. Given any activity graph like the previous one, explain how you would determine the minimum time to complete all activities. All right, so I want you to think about this for a minute. This example right here is just, it means nothing. It's just an example of a pathway. The longest pathway here, there's 2 longest pathways, 3 actually. ABC, AEC, and DEC are all 3 activities long. But how do you know that? The best way to determine how you determine the minimum time to complete all activities, you would have to know the time of each activity, first of all. And in order to know the total time of activities, you would have to sum all possible pathways. So let's look at all the possible pathways. There's ABC, there's AEC, there's DEC, there's AE, DE, and then there's FG. How many of you didn't even notice the AE pathway? You see, if D takes a half hour and A takes an hour, we can't start E until A is done, even though D is already complete. How many of you even saw that? Those are the things that project managers are really involved in trying to take care of. They want to logistically take everything and put it in order. They have to understand the time for each activity, and they need to know the prerequisite activity for all activities. That way they can get everything done. My first experience with this was setting up a brand new store for Walmart, and let me tell you, the project manager must have a brilliant mind or a good computer program. Guess what? They have good computer programs that help them determine exactly how many truckloads need to show up every day. And it takes about 30 to 45 days to set up a Walmart. And it's a lot of work and a lot of people and a lot of management. So anyway, that's just, let me digress. Okay, activities that cannot be delayed without increasing the minimum time for completion are called critical activities. As part of your vocabulary, it'll be up on your word wall, so check it out. Given any activity graph like the previous ones, explain how you would determine which activities are critical activities, okay? So, if you find the pathway of the minimal time for completion, it is safe to assume that all activities on that pathway are considered critical activities, because if you delay any of those critical activities, you will increase the minimum time for completion. Does that make sense? Let me rephrase that. When you find all activities that are on the pathway that have the most time to complete all activities in that path, that is the minimum time of completion. If you delay any of those activities, you're delaying the minimum time for completion. And just like it says here in this slide, activities that cannot be delayed without increasing the minimum time for completion are called critical activities. So any activity on that pathway that is the minimum time for completion is a critical activity. All right. Determine the minimum time required to complete all activities shown in the graph. For the following activity graph, the times given for each activity are in hours. Now notice this dotted line from D to E. The only reason it's dotted is to show that it goes behind F. It is still a prerequisite for E. Interesting, huh? So let's look at our pathways. A, C, E, A, C, F, A, D, F, B, D, E, and then B, D, F. All right, let's look how much each one is. All right, first pathway, let's go ACE. That's 3 hours plus 5 hours plus 2 hours. That's 10 total hours. All right, ACF, 3 hours plus 5 hours plus 1 hour, that's 9. ADF, 3 hours plus 3 hours plus 1, that's only 7 hours. So far, our longest pathway is ACE. How about BDE? 4, 3, 2. 4 and 3 is 7 plus 2 is 9. Last pathway, 4, 3, 1. That's 4, 7, 8. So our longest pathway is ACE. So our minimum time of completion, in order to complete all activities, we assume, first of all, that all activities happen simultaneously. Okay? So if that's the case, the minimum time for completion would be the longest time pathway in the activity graph, and that is ACE, or 10 hours. All right? It also means that all activities on that minimum pathway, ACE, are considered what? Which activities are critical activities? For the following activity graph, the times given for each activity are in hours. In the last slide, we determined that ACE was a pathway that took the longest, making it the minimum time to complete all tasks. It also means that any activity on that pathway, activity A, C, or E, are considered critical activities, because critical activities are defined as activities when delayed will affect the minimum time of completion. And if we delayed A by any amount of time, we would delay the minimum time of completion of 10 hours. Same thing with C or E. If we delay any of these, we would delay that 10-hour minimum. All right? Time of completion. All right, how long could activity F be delayed without affecting the overall completion time? Well, let's look. How many pathways run through F? We have ACF, we have ADF, and we have BDF. All right. Now, it's important to understand that the minimum time of completion is 10 hours, that ACE. ADF is 7 hours. BDF is 8 hours. But I want you to concern yourself with the total time to get to F. There's 2 prerequisites to get to F, C and D. Okay, and then furthermore, C has an activity that is a prerequisite A. D has 2 activities, A and B, that have to be completed before it can be completed, all right, or before it can be started. So B takes 4 hours, D takes 3 hours, it'd be 7 hours before you can start F, okay, through that pathway. A takes 3 hours, D takes 3 hours, it'd be 6 hours before you can start F on that pathway. So BD delays it, you can't start F for 7 hours. But look at this, AC is 8 hours. So the fastest time you can get started on F is after 8 hours. That means after A and C are completed. So if we have 8 hours and an hour to complete F, that means we complete that pathway in 9 hours. So in other words, ACE is a 10-hour pathway. We have 1 extra hour on ACF, so we could delay F by only 1 hour. Does that make sense? Okay. All right. How long can D be delayed? All right. The only prerequisite for D are A and B. B is 4 hours, so we can't start D for 4 hours. But there is a pathway after D1 and E2. So we can only delay this pathway 432, which is 9. We can only delay D by 1 hour. Because if we delayed it by more than 1 hour, we would slow down this pathway BDE to be longer than ACE. So 4, 3, that's 7, plus 2 is 9. If we added 1 more hour to delay D, that would make it 10. Any more would delay the total length of completion longer than the ACE. Okay? So let's move on. All right. What if activities F and D were both delayed by 1 hour each? 4, 3, 1. If we delayed D, it would not postpone this activity by 10 hours. So 4 and 3, that's 7, 8, 9, 10. But let's look at this. 4 and 3 is 7, plus 1 is 8. F is also delayed by an hour. That makes 9, 10. It would not delay the completion. Notice that D is delayed by an hour. It delays 2 pathways, BDE and BDF. But in that delay, we still allowed enough time to get completed in the minimum time of completion through pathway ACE of 10 hours. And even though F was delayed by an hour, notice that ACE is another pathway that comes through F, and it does not postpone it long enough either. So let's look at it. Here's what I'm talking about. 3 plus 5 is 8. Delay F an hour, that's 9, plus 1 for F, and that's 10. Same thing here. 4, okay, plus 3, we delay it by an hour, so it's 5, plus 3 is 8. Delay F by an hour, that's 9, plus 1 is 10. So either way, we still do not postpone the minimum time of completion that originally started of 10 hours. All right, so what is the definition of a chromatic number? Also on your word wall. So it depends on whether or not you know what chromatic number is. That's kind of a review, I think. No, chromatic number is not a review. It's brand new. It is the minimum number of, let's go back, the minimum number of colors required to color all regions on a map where all adjoining regions or regions that share a border have different colors, okay? We can also define it using graphs. It's a minimum number of colors required to color all edges that span between all vertices, so that all vertices that are adjacent have a different color. I'm sorry, the number of colors that vertices are colored so that they have different colors if they have an edge between them. Okay, I apologize. So anyway, I'm gonna launch you with this. First, have a definite, clear, practical ideal, a goal, an objective. Second, have the necessary means to achieve your ends, wisdom, money, materials, and methods. Third, adjust all your means to that end. That's from Aristotle. And I can tell you right now, As someone that was really ready to start his whole life over and be a Renaissance man and live out off on the land, I found some land that was cheap enough for me to buy, but I didn't do enough research to make sure that I had all the necessary things to live. And I would suggest you do all your research, okay, and get all the means in order to achieve those ends. The first plot of land I bought, I had enough money to get the electricity, but not enough to drill a well. It's very expensive. So I had to go without water for a while. And now with this new property, I've got water, and the cost to get water was so expensive that I had to postpone getting electricity for a little while. But, you know, that's same thing. Make sure you have a definite, clear, practical ideal, a goal and objective. Second, have the necessary means to achieve your ends. Do your research. Know what you need, and make sure you have all that before you begin any endeavor. All right. So y'all have a nice day. There is an activity, an assignment in the Google Classroom for SAS 9 called map coloring. I'm sorry, not map coloring, activity graph. Please go and take care of it as soon as possible. Have a ball, y'all, and be blessed, be a blessing.